Welcome to another teardown and investigation video. I'm a little bit afraid of powering up this unit. It's actually really big and heavy. I don't really understand what kind of kilowatts this can generate. I see some buttons with volts and current set up. So there's an arrow up and down and some minimum and maximum and overload and what is the display reading? What kind of, I don't know. The internet doesn't really tell me anything. Of course, if I Google ion pump supplies, I find a lot. So this is definitely a thing. But if I Google the IPS-04 or DL instruments, I don't find a thing. So is it safe to power this up? Definitely I shouldn't stick my fingers into anything. Let's look at the back. And here is the back. Wow, look at this nice filter. So we don't get all sorts of dust and stuff in there. Do not disconnect if power is on. And this is the really good high voltage BNC version. I think it is originally rated for 15 kilowatts. It is loose. Yeah, well, this is the thing with this really tall BNC. It is very fragile. It is out here. It's easy to, bump stuff into it and break it. And then again, we find this very old AC mains. Doesn't say, yes, it says 220. Okay, I can provide that. And this is also Czech Republic. And then this connector. Look at this connectors come. Connector 1 and connector 2 is for something else. We don't know what it is for. This is where all the magic is, maybe. I like the side panels, and all the sides contains screws. That means we can access the unit from any side. Ooh, it's full of all sorts of good things. This is some high voltage stuff. I think we should actually take off the lid before we power this up and see what is inside. That is a good idea, right? Yeah, let's do that. So that was only 4 screws. Super easy. Let's see. Oh, I think that was the wrong side. Oops, sorry about that. Wow, look at that, baby. That is interesting. I've got some RAM and EEPROM and stuff. This is maybe what a 51, an 8051. Let's just see if I was guessing right. What is that? Diodes, power diodes. Wow, a fan. This fan is just like the one from a microwave oven. Oh, it's stuck. Almost not moving. Wow, look at that. So this thing can give a lot of power. And look at all those diodes. That is bad. I guess this can do a lot of damage. This is exactly where you're not going to stick your fingers, alright? And this is the... Wow, what is that? A shield around the transformator, and this is... Let's have a look at that. So it's ferrite. So this is a switch mode this size. Wow, like a whole hand. This is some nasty. And look at that. Odd. Can I get some light down there? Come on. Why is that a wire around the resistor like that? That looks really weird. Yeah, now you can see that. That looks weird. Is it for holding it in? Just a mechanical support? Oh, what? Ooh, a lot of capacitors. I can't wait to power this up. Yeah, maybe we should just do it and see what happens. Yeah, so this wire goes all the way to the output. They goop this in. Seems like it's almost very, very loose and some extra loose wires like that. This is a little bit like how you're doing it. Maybe there's an easy way to lift up with this PCB. This case look a lot like the other Czech product that I did a teardown on like a week or two ago. Look at all the different mechanics, the way that the case is assembled. It looks a lot like that. And also that you can just unscrew everything like this. And also the fact that they're using a lot of modifications and hand doing things. The other unit was full of that stuff as well. So I think we should maybe take off some more sides so we can see what's going on. Or should we power it on? Yeah, should we power it on? I feel like it. Okay, so here's the thing. We got 220. Yep. Okay, so here's the deal. If there's any kaboom, we stop the video and call it a day, and then I continue tomorrow, okay? This thing draws 100 watts, so I will definitely call it a turn off. Turn it off, yep. Oi, 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 oi. See ya. This is definitely what you want to do. When you're powering up some funny electronics, of course you want to take a thermal camera and investigate while you power it up. And then you can turn off the power. It's quite a long time ago since this was powered, just for a short while. And I see very, very hot components in here and also up here. So this is worrying me a little bit. So something is here. I'm really sorry this the thermal camera can't deliver a video feed. So it's just going to be something like this, all right? I just turned this on a few seconds again. I don't know if you can see this, but it was 150 degrees down here. So if I didn't turn it off, something would definitely blow up down here. So this up here is not hot. This is just the radiation from something else generating the heat up here. But down here there's definitely something bad going on. So I need to investigate what is wrong. Look at this detail. So all those connectors, they're exactly the same size and type and whatnot. 16 pin. But there's like no names, markings, numbers anywhere. So how the heck do I know where to put them if I pull them out? That is a little bit stupid. I would expect some numbering here. So this is the mains input. Alright, fine. Mains input, mains fuse, some, maybe this is the voltage selector. I don't know. You can only guess. This looks like 230, and then the fan is maybe 110 and then 220. That could be the way they did it. The on-off switch, and again mains cables, and here we see a mains transformator, and this is what runs all the logic and controlling. And there's definitely a microcontroller here. Is it possible to get the light in? Hello, what is your name? Alright, so what I want to do is try and see if I can boot up the logic without the power board. There's definitely something wrong up here. So also look at this really nice power board. It is clearly that everything here is high voltage and dangerous and really don't touch. You can see the distance between all the tracks. And also I want to show you, I don't really want to touch this area. Because look at that. That is some bad. A lot of capacitors here. So 4x3. And they are, why isn't my camera not in focus here? Hello. So those are a lot of volts, and all of those in parallel. And see, they're connected with a tiny little wire. I don't know if I can make this visible, but there's a tiny little wire up to the rectifier. And the rectifier system is here, connected to the transformator output. The other end goes to the chassis. So if I look at the diodes, that means it is minus a lot of kilovolts, and then a series resistor for current protection. So this is what we get. But still I want to know what is going on down here in this area. Those two green resistors, or in this area, is where we get all the heat. Something bad is going on here. So now we are a little bit more in. Let's have a look what we got. It's actually not that bad. Yeah, well, anyway, I think this heatsink is really cute. Don't you think? I can't remember seeing anything like this before. Oh, I just love it. That is just brilliant, isn't it? So this is the main controller board, and down here is the big nasty power board where all the bad things happens. And obviously, this is our mains input. So what have we got here? Goes through some magic thingy under there, whatever that is. Is this a common mode choke, or is it a filter of some sort, or if it's current transformator? Nobody knows. By looking at the value of those capacitors, 100 microfarad, 350 volts, and they are all in parallel. So I guess there is a rectifier somewhere, right? And look, we got a rectifier, fuse, and then our mains voltage. So we are not going to touch anything because we just powered this up like a half an hour ago. And in this area, something very, very hot is going on very, very fast. Now that I can see this more clearly. Wow. It is really, really fantastic. TDA, what the heck is that? Controlling. So what is that? Optocouplers, and then the gate drive or pre-drive, and those some trigger transformators, and those are probably FETs or IGBTs. And what is that? Current transformator, and then we got the big nasty transformator, and then a flyback diode capacitor. This is probably the flyback system. Alright, so I don't know if I dare to actually get this working. Otherwise, it is maybe more safe just to let it go. But we'll see what happens. Maybe I should sleep on it, and then we'll see. You can also see some really nasty capacitors down there. Lots of voltage, and I also see, it's maybe not that easy to see on the camera, but down there we see the blue capacitors. They got some brown colors on them. There's maybe a reason for this being broken. What have we got here? Some other sizes of capacitors in parallel. What is that down there? Oh, come on, man. Why can't you just video that? See? This thing is going to kill me, I'm telling you. I found something. Milliamps? Now I'm getting worried. Okay, microamps, alright, but milliamps? That is bad. And then kilowatts with 3 digits. This is not good. I hope there's a decimal somewhere. Alright, so we are definitely in. I cut off some of the wires here, so that means I can have the controller board lying up here. Of course I will put some isolation here, so that means I can put the controller board up here, and then I'll be able to access everything down here and play around with this, see if I can figure out what is going on. It is going to be with the thermal camera, because I'm not touching anything before I get a little bit more familiar with the circuits. It also looks like it's really, really old. And everything here is done with kind of old tech parts, and the smell is also really bad. And yes, I will remove this washer. This is something I dropped. But I don't really see any burnt, blown up components. I can see those resistors. They look like they have been hot. Maybe those are the ones getting hot. Maybe there is a big explanation for this. But it's not supposed to draw a few hundred watts in standby. I didn't touch or enable anything. So maybe there is a short somewhere. Oops. Reading the data sheet and the pinouts before you do the PCB layout. Yep. That is important. Also the transformator, there's a flange on both sides for screwing this to something. And yep, it is where this resistor was supposed to be, so it has to be removed. Well, who am I to judge somebody else? I have done the same mistakes once or twice in my career. Oh, look at that. This solder job here is just absolutely rubbish. Look at this one. Yeah. It is not soldered. Good job. Or better luck next time. Just some op amps there. Voltage on the display. Current output. Balance, whatever that is. 0. Okay, so this will be all sorts of analog adjustments. I really find it funny to see this kind of layout. Why would you do it like that? Absolutely. Look at that. Left, right, left, right, left, right. And then it's obviously exactly the other way on the other side. And this is how you did it in the very, very, very first beginning of CAD. It was just left on one side and right on the other side. That was the only way they knew how to do it. Don't you just love it? Look at this. I'm still getting really, really hot components down here. And it frustrates me. Now I'm going to turn it off. That I disabled the fuse like this, and all the parts here still gets burning hot. How the heck is that possible? Because this is the output from the rectifier, right? That goes through the diodes and all the way up to the capacitors, and this is what's driving everything here. So why are they hot? How is that possible? This we need to investigate. See this. The power off the thermal camera. Now it's off. When I turn it on, okay, maybe we should move the light like this. Okay. Ooh. So those two are in rush. And those are like bleeder resistors. Let's turn it off again. Wait a little bit for cooldown. We can also crank down this light a little bit. So I guess we can better see the camera. See? Clearly some inrush. This is just the power of thermal camera. It's amazing, isn't it? I am now ready with another test. I put on some WD-40 and now the fan is blowing a lot better, and this helps a lot with the heating of the resistors. I'm actually a little bit worried. So I think maybe this was the intention in the design, and this only works if the fan is running at super high power, and then the resistors maybe will be okay. I'm now measuring the high voltage. So since this is a negative supply, I got my 13 kilovolt 100:1 probe, and I got the scope up here, so I should be able to see the first 3 kilovolts on the screen here. And everything is connected. I put the fuse back, so that should be ready. I also managed to figure out how this user interface works. So let's try and power this up again. Now the fan is running. Oi, did you see that? A lot of kilovolts. 6 kilovolts. Yay! Let's turn it off and see the scope. Ha ha ha! But it says 6 kilovolts here. And yes, I got 1 kilovolt per division. So that is right. Ooh, fantastic. We got the kilovolts. Okay, let's try again. Now I've adjusted a little bit more on the scope. Turn it on. And then I think I don't touch anything at all, and it just goes on. We got the 6 kilovolts of output, and then you just click 6 kilovolts. But I think when you are in 6 kilovolt, you can hit set. So that is all the different currents. I didn't find a way to change the kilovolts. No, I cannot change. So, but I can change the current. How many microamps? So now it's blinking here in microamps. Then I can. Oops, let's try again. See, now it's blinking down here. Oh, now it's blinking something else. I don't get it exactly what is going on. It is a little bit weird. What? Okay, this one, fine. This is milliamps. Maximum. So this thing can give 200 milliamps. Are you kidding me? Oi, 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 oi. This is bad. No. So when this is blinking, see? Then we can crank down the milliamps. Still real bad. Milliamps. So this is the current levels, milliamps. And now I'm in set for those two. This is a little bit weird. Really odd user interface. I don't understand. But it is running. I got 6 kilovolts output here. And if I look carefully on the scope, I also see 6 kilovolts of nice, clean, high voltage. And don't touch the yellow wire. Oy, 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 oy. So I think it's time to turn it off and pack it all together. Let it run a little bit and see the temperatures again. But thank you for watching. I found it's impossible to get this in focus. See the big brown resistor? So this is how it's measuring the output voltage, and then it goes down to a little capacitor filter, an op amp, And this is maybe the loop filter that I've been playing with here. So this is the voltage feedback. Also see the diodes. They are mounted on copper pieces they made specially for this, so they are cooled really well. So I think this can actually generate quite a lot of power. And it is beautifully made, this high voltage section. 10 nanofarad. This is the weirdest input filter. This is mains. And down here you will see some capacitors and stuff. And then the other common mode choke is looking a little bit weird. And there is no output if the fuse is removed, but all of this is still powered somehow. So this fuse is maybe just for the last output stage. But yeah, 6 kilovolts, and I haven't figured out how to make it variable from the front, because I think it is made for current limited loads for some reason. I would prefer if I had a variable voltage supply, then I could use it for something more practical.